We got trig functions of angles today, really trig functions of any angles, and a lot of stuff in here, so let's get to it. We did right triangle trig already, and I've got a picture of a right triangle here. And if you look at this right triangle, it is on the coordinate plane. And basically, if you think about any point on the coordinate plane, you can get to that point, arrive at that point by, having a hard time here, by, come on now. Okay, never mind. By going this far on your x-axis, this far on your y-axis. Of course, the shortest distance is a straight from the origin to the point, but you can also get there going right up, right down, left down, whatever. And it gives you a point on the coordinate plane, which also forms a right triangle. The R is obviously the shortest distance to it's the line straight to the point, and it's the hypotenuse of the right triangle, which is important. So the distance of R, the length of R is this right here. It's the square root of x squared plus y squared, which is the Pythagorean theorem, by the way. All right, so that's how you find R. It's x squared, the square root of x squared plus y squared. It's the distance from the origin to the point. And if you think about the right triangle, it's the hypotenuse. A couple things I want to drill in your head. The x, I want you to think cosine. Cosine is x, or x over r. And because it's the adjacent over hypotenuse, that's why it's x over r. Sine is y over r because sine is the opposite over hypotenuse. Tangent is y over x because it's opposite over adjacent. These three, the cosecant, the secant, and cotangent are just reciprocals of those three. So just like the right triangle trig with SOHCAHTOA, this is the same thing except it's on the coordinate plane. That's the only difference, and it's really the same exact thing. The signs, you need to know the signs on the quadrants. You should know these already. In quadrant 1, everything is positive. In quadrant 2, it's like this. It's plus minus, which means your cosine is negative, and your sine, I got that backwards. Oh my gosh, it's a great video. It goes like this. Sorry about that. The cosine is negative and the sine is positive. Remember, cosine is x, sine is y. Tangent, down here, everything is negative except tangent's positive because tangent is x divided by y, or y divided by x. So it's positive, but cosine is negative, sine is negative. One more time that I blew up here. Cosine is negative, sine is positive. Down here, you got to go plus minus, which means cosine is positive, sine is negative. Okay, and they gave you a little ACTS thing there so you can kind of learn which one's positive. You should know that anyway. I'm not going to worry too much about that. You should know where things are positive and where things are negative. All right. General angles here. It says find sine 135. Okay, now, sine 135 starts here. You can see a little red arc drawn right there. It starts at the standard position and goes to here. Okay, now when you go 135, I want you to realize this. You're also 45 degrees away right there. You're 45 degrees away from the x-axis, which means you basically have a 45, 45, 90 triangle. Okay, so let's say like they're not giving you the x here like exactly what the x coordinate is, but it doesn't matter because it's a 45, 45, 90 triangle. And the way a 45, 45, 90 triangle works is like this. And you should remember that from geometry. The hypotenuse is square root of 2 times as long as the legs. So if they ask you for a cosine, remember cosine is the x, you do x over r. Cosine is the x. So cosine of 135 is going to be x, which is the 1, except in this case, I'm actually going this direction, so x is negative 1, negative 1, r, which is always positive because it's the square root of x squared plus y squared, or the hypotenuse, which is square root of 2. Now, you can't leave it like that. Obviously, you can't leave a radical in the denominator, so you pull the radical up, take it around the bottom. There you go. It's negative square root of 2 over 2. Every cosine 45-degree angle is going to be square root of 2 over 2, either positive or negative. It's negative because it points in the 135 is in the second quadrant. Remember, this is 180 right here. That's 90 up there. So it's in the second quadrant, and x is negative in the second quadrant, so it's negative. Tangent 390, you can see how they do that right here. Started at the standard position, went all the way around and back up 30. So really, they created a 30-degree angle there. Now, 30-degree angle means the angle up here is 60. So you have a 30, 60, 90 triangle, which is one that you should know from geometry. Everything is based on the short leg. So if the short leg is 1, the long leg is square root of 3, and the hypotenuse is twice as big as the short leg. That's what you use in geometry for a 30, 60, 90 triangle. Okay, so tangent 390, which is in the first quadrant, by the way. And in quadrant 1, everything is positive. So x is positive, y is positive. Remember, tangent is y over x, or opposite over adjacent. So I'd go 1 over the square root of 3. That's a terrible 3. Just rationalize that, get the radical off your denominator. And there it is. It's positive again because it's in quadrant 1. Reference angles. This is a huge deal. Reference angle, I'm going to read the definition here. It says let theta be an angle in standard position. The reference angle, little bar over theta, associated with theta is the acute angle formed by the terminal side and the x-axis. So basically it's this. It's how far is your angle from the x-axis? How far is that? How far is that? How many degrees is that? Or radians? How many degrees is that? Or radians? That's all the reference angle is. How far away from the x-axis is it? Okay, so find the reference angles for these two. First one says 5 pi over 3. Okay, 5 pi over 3, if you think about it, 3 goes into 5 one time. So that's really like this. Let me just erase what I just wrote. I'm having a hard time today. Sorry about this. It's really 1 2/3 pi. Okay, remember we've looked at these before. There's pi over 2 right there. There's 1 pi. There's 3 pi over 2. There's 2 pi. So if I go 1 pi and 2/3 pi, if I go 1 and then 2/3 pi again, I'm going to right there. So there's my angle. Now, reference angle means how far away from the x-axis. How far away? How many radians is that? Okay, that's 2 pi. So how far away is 1 2/3 pi from 2 pi? And the answer is 1/3 pi. So the reference angle is pi over 3. Okay, because I'm 1 pi over 3 away from the x-axis. That's our reference angle. That's really important. Let's look at the degrees here. The degree says 870 degrees, that's huge. Okay, so in degrees, I'm looking at 0, it's 90 degrees up here, 180 over here, 270, 360. Now, 870 is huge. That's like going around one time, that's 360. Go around again, that's 720. Go up here, that's 810. Go 60 more, there's 870. That's around and around we go. That's 870. So the question becomes, how far away from the x-axis are we? How far away from right there, the closest x-axis? Okay, so 870, this was 810. This ended up being 810 up here. I'm having just my things moving. That's 810, which means over here is 900. So how far is 870 right here from the 900? And the answer is 30 degrees. It will always be acute. It will always be less than 90 degrees. In radians, it will always be less than pi over 2. Always less than pi over 2 because it's got to be acute. How far away from the closest x-axis are you? Okay, so here's our steps. Here's what we're going to do. When they give us an angle, no matter what it is, first thing we do is we're going to find the reference angle. We're going to figure out the sign that our answer is going to be of theta based on what quadrant it's in, and then we're going to find the value of the reference angle and put that sign with it. That's basically what that says. So there's your steps. If you want to take a picture of that or whatever, that's exactly what we're going to do in the next slide. Okay, sine 240. Okay, sine 240. I'm not going to draw these all the time, but while we're starting here, I'm going to go with this. That's 180, 270. Okay, so 240 is going to be almost a 270. It's going to be right there. So there's my angle. Okay, so here goes. How far is it from the x-axis? It's 60 degrees. So what I'm going to really do is I'm going to find sine 60 degrees. And again, that's 30, 60, 90. That's an angle that, we need to know what that is. And so I'm just going to say it. Sine 60 degrees is square root of 3 over 2. Right? And that's from that chart we saw the other day. And because it's in quadrant 3, x and y are both negative in quadrant 3. Sine represents the negative, represents the y. So my answer is this, negative square root of 3 over 2. Okay, that's kind of crazy, kind of fast, but that's kind of how we're going to roll. Let's look at the second one, tangent 495. Tangent 495, I'll draw it. I'm not going to keep on drawing these things because I think eventually we can get to where we don't have to draw them anymore, and hopefully it's not going to be a long time. That's 180, we got 270, 360. Okay, here we go. If I go all the way around, that's 360. If I go 90 more, that's 450. And if I go, it just disappeared. That's 360, 450, and I'm going 495. So I'm going 45 degrees more. Did you catch that? 45 degrees more, which means, come on now, which means our reference angle right here is 45 degrees. So what I'm thinking is, okay, what is tangent 45? That's what I'm thinking. Okay, tangent 45, that's one we know. It's just one. Now, because it's quadrant 2, and tangent is y over x, in quadrant 2, y is positive, x is negative. So if I do positive divided by negative, that's negative. So tangent of 495 is negative 1. That's the value. Okay, two more this time in radians. This one says sine 16 pi over 3. I'll do this again. I'm not going to keep drawing these things over and over again. You got to get to where you can do this kind of where you're at. Okay, now 16 pi over 3 is really 5 1/3 pi. So that means if I go all the way around, that's 2 pi. There's 3 pi, 4 pi, 5 pi, and I'm going 1/3 more. Okay, so I just went 1/3. I really went 1 pi over 3. So pi over 3 is 1/3 pi more past the x-axis. That's my reference angle right there. How far away from the x-axis am I? So I'm really doing this. I'm really thinking, okay, what's sine pi over 3? And everybody knows sine pi over 3 is square root of 3 over 2, right? And because it's quadrant 3 down here, quadrant 3, x and y are both negative, my final answer for sine 16 pi over 3 is negative square root of 3 over 2. No big deal. Okay, last one in the video. This has been a pretty long video, sorry about that, but it's so important. Sine negative pi over 4. So that's 0, that's negative, not negative, it is negative 90, but we're in radians. It's really negative pi over 2. So if I go negative pi over 4, I'm going halfway to there. That's where that angle is. So how far did I go? How far from the x-axis am I? I'm pi over 4 away. Now, I don't have my secants memorized, so I'm going to do cosine pi over 4. Cosine pi over 4 is square root of 2 over 2. Now, secant is reciprocal of cosine, so I'm going to do the reciprocal of that, which would look like this, by the way. It would look like this. So if I rationalize it, you would look like this. If you cancel the 2's, it's a long method to get there. It's square root of 2. Okay, now, got to figure out my sine. It's in quadrant 4. Quadrant 4 is positive, negative. Cosine is the x, which means secant is the x. So that's it right there. That's your final answer, just square root of 2. It's got to be positive because it's in quadrant 4. And it's reciprocal of cosine. Guys, that's a lot on a video. This is maybe one, I wish you would watch this one again after the lesson tomorrow. It would really help you. I promise it would. And you just got to hang in there. Okay, so I'll see you in class tomorrow.